Okay, so the plan today is to go ahead and talk about any questions you might have on your quiz. The average was a little lower than what we're normally accustomed to in here, so hopefully we'll have a few. After that, we'll go ahead and finish up 1.7. We'll go ahead and start 1.8. Tomorrow we'll have questions over the 1.6 homework. We'll go ahead and continue 1.8. So for the people who are not going to be here tomorrow, you'll at least have the idea for what's going on in the lesson today. Tomorrow is just practice. We're not going to move on to any new material. And then on Friday, we've got the group activity where we're going to be practicing it. So we'll get to that in just a second. I calculated your score wrong? Okay, I'll take a look at it. Okay. And then the important thing is next week on the 30th, that's when your first exam is going to be. So it's going to cover topics 1.4 all the way to 1.7. Okay, so we're finishing up 1.7 today. 1.8, we are starting it, but that will not be on the exam. Okay, I think that's everything I've got, unless anybody has any questions. Okay, let's get to it. All right. Questions on the quiz. Number 3. Okay, so number 3, we see the polynomial. So what we're wanting to do is figure out where the function f is greater than 0 and where it's less than or equal to 0. Now remember, when we're talking about 0, that's the x-axis. Okay, so if we're saying greater than, we want to know where it's above the x-axis, less than, we want to know where it's below. Okay. So let's see, if I want to know where it's greater than, well, I'm just looking for any part of the function that's greater than or above 0, the x-axis. So I've got two intervals here, one from -3 to 1. Now I'm going to use parentheses because we don't have equality. So -3 to 1, union, and then the other one picks up at 4, and then continues forever. Okay, so we'll say infinity on that one. And then for less than 0, we're looking for any part that is below. So this one, we're coming in from -infinity to -3. Now this one, we do have equality, so I'm going to go ahead and put a bracket on there. Union, and then we have one between, looks like 1 and 4. Okay. Right. Good. Okay. What else? 2. Let's take a look at 2. All right, now on 2, we're finding the degree, we're finding the roots, and then we're listing the multiplicity. In fact, the only difference between numbers 1 and 2, number 1 was factored for me, so we have to go ahead and break things apart. So this difference of squares, this is going to be x minus 6 times x plus 6. What two numbers will multiply to give me 6, but had to give me -5? Okay, there we go, -2 and -3. So this is going to be x minus 2 and x minus 3. So once we get all my group factors, we set them equal to 0. We go ahead and find my roots. So these first two would give me a plus or minus 6. We got a 2. We got a 3. Now, every one of these groups has a power of 1. So that means the multiplicity is 1. So that was the one multiplicity you don't have to write. If you went ahead and wrote it, fantastic. If we're going to talk about the degree, let me go ahead and take this off real quick. You could multiply the two parts together. All right, but I would just look at each one. Since this one's not going to expand, the largest power we're going to get out of that one is x squared. Same thing for the trinomial. So the largest I'll get out of there is the squared again. So multiply those together, we should have x to the 4th. So 4 being my degree. And Pearson, was that you? Or who asked about that? Was that? Akil, was that you? Okay, does that make sense? Okay, what else? Next. 4. Let's take a look at 4. Okay, so for this one, solve the inequality. 5x, x minus 8 squared, x plus 3. So this is a polynomial inequality, and we're going to use a sign chart. So it's already factored. So if I set each of these 3 equal to 0, I've got 0, 8, and -3. Okay, so these are the values I'm going to place on my sign chart. So we have a -3, we got ourselves a 0, and we got ourselves an 8. Open or closed? Okay, open because we don't have equality. And then what we want to do is go ahead and find whether these intervals are positive or negative. So we just choose a number. Like, for example, between 0 and 8, let's say I want to choose 2. Okay. Well, I'm going to plug that in for every one of these x's here. Okay, so 5 times 2, well, that's a positive 10. Now, 2 minus 8 is a -6, but this group is squared, so that's going to be a positive. And then 2 plus 3, that's another positive. Remember, we're not interested in the actual number. We just want the sign. So 3 positives will give me a positive. Okay. So if I continued in that way, I believe, if I remember right, the pattern should be plus, minus, plus, plus. And which is going to be my answer? The 3 positives or the 1 negative? There you go. It says less than 0, so I'm looking for the 1 negative. Now remember, the sign chart is my work. So my final answer should be everything from -3 to 0, but not including those endpoints. Let's see. See, you should have 4 points taken off. I don't know what. And that was there?
Yeah, because we added others.
I'll look at that in just a second. All right, so I owe you a few points on that. All right. What else? 5B. Did anybody want me to go ahead and do 5A while we're at it? Okay. So we're given a table, and what's important here is that it says it's an even function. So you remember in the notes, we used this rule right here, where if I take the opposite of x, okay, that has no effect on the outcome y. So by changing the sign of x, I still get the same y value. So if it's a little easier for some people to think of it this way, then xy, if I go ahead and reflect it across the y-axis, well, then only the x value is going to be changing. That's another way to look at it. So what I want to do first is find a and b. So I'm looking here. Okay. So I've got -3a. Well, I'm going to want to be looking elsewhere in the table, knowing that we're changing the sign of x. So I'm going to look here because -3 is changed to a +3. But we see that the y value stays the same. So if this is a -5, then that means a has to be a -5. Okay. And then we'll do the same thing when it comes to b. All right, so 6 is associated with b right here. So we're taking the sign difference. That means I'm looking right here. So both 6 and -6 should be giving me a +2. Okay. Now, for the average rate of change, I want to go ahead and find that over the interval from -1 to 9. Okay. Now, we know 9. If I go ahead and plug that in, I'm going to get a 7, but we don't have -1 in the table. So I went ahead and added a little bit over here. Okay. So if we're using the same idea, so 1 or -1, either of these will give me a 4. And then I'll just go ahead and write it out using the function notation. So it doesn't matter, which one we start with. So let's say f of -1 minus f of 9 over the difference of the y's divided by -1 minus 9, the difference of the x's. Okay, so f of -1, we got that 4. F of 9 is 7 over -10. Simplifying, that's a -3 over -10, so we should be getting 3/10. Bless you. Okay. Is that good? Where'd the 4 and 7 come from? So they are the y values of these right here. So if I plug in a -1, I should get a 4. If I plug in a 9, I should get a 7. Well, we're not technically plugging them in, whatever the function h looks like. All we know is that, like, for example, if I have a 9 and I were to plug it into function h, I know the corresponding y value is 7. Now I was able to figure out what corresponds to -1 because it's an even function. So we're not technically evaluating anything ourselves. It's just, okay. All right, is that good? Is there anything else? 7. Okay, so 7, I think, is the slope problem. Okay, so let's see what we got here. The graph of f is shown. Which of the following statements about the function f is true? So all of these are talking about the rate of change or slope. Okay, so whether it's positive increasing, negative decreasing, all of that is with the slope. Okay, see that? Okay, all right. Now, let's just talk about the slope itself, for example. This is a curve, so the slope is constantly changing. So how would we find the slope at an exact location? What have we been using? Starts with a T. Tangent lines. Okay, so if I go ahead and start drawing some tangent lines here, all the way around, okay, well, every single one of those lines is dropping to the right. So we're dealing with a negative slope. So that immediately eliminates A and B. Okay, so it's negative. Now we just have to figure out if it's increasing or decreasing. Okay, got it? Okay. Well, let's see here. We're going from a negative slope, a steep, to a more horizontal. Remember, what's the slope of a horizontal line? 0. So we're going from a negative to a 0, so we are increasing. Also, if you take a look at it, I mean, it's concave up. That means the slope is increasing. All right, what else? 9. Here's 6. Okay, let's take a look at 6. Okay, so it's very similar to number 5, except that this one is an odd function. So here was the rule we had. If I change the sign of x, that changes the sign of y. Or if I went ahead and wrote it out, any point xy that I rotate 180 degrees around the origin, negative x, negative y, or I should put an arrow there. You know, both x and y will be changing sign. Okay, so if I'm taking a look at part A, I want to find the values of C and D. Okay, well, C is associated with this 5 right here, right? Well, we already know the x's are changing signs. So if I'm looking at a positive 5 here, I want to look elsewhere in the table where there's a negative 5. But in this one, the y's are changing as well. So if this one gives me a negative 3, well, then what should C be? Should be a positive 3. X and the y change signs. Same thing if I look at D. Let's see here. So D is associated with 6. So I'm looking elsewhere in the table where I have an opposite to that, which would be right here. So if negative 7 is this x, then that means 7 has to be D. All right, then we're going to use the same idea to go ahead and help me fill out this last part. So this is what I told you yesterday. I said that, I had a blank for each of these two, but I forgot a blank for the actual sum. So just, to put it to the right. So let's see here. Okay, I want to figure out what k of 8 is. So I'm looking in the table. Well, I know that a negative 8 will give me a negative 9. So if this really is an odd function, then a positive 8 will give me what? Positive 9. Negative 1 is what I'm looking for now, so I'm looking at the table. Well, I see that a positive 1 will give me a positive 2. So that means that a negative 1 will give me a negative 2. And then I just want to add those together. So 9 plus negative 2, that's a 7. Okay. Anything else?
What was the answer to the second question on number 3?
The second question on number 3. This one was, for the second part, it would have been negative infinity to -3 bracket union bracket 1 to 4 bracket, because we're looking for anything below the x-axis. Okay. All right. Anything else? Okay. Well, if anybody's looking to retake this, you have until next Thursday morning. That's the morning of our exam. You just got to have 1.5 finished and completed before the retake. So let's go ahead and put that to the side. Ryan, remind me at the end. I'll go ahead and take care of your quiz. But let's pull out 1.7 and let's wrap that up. Okay, so here's 1.7. Did anybody need a copy? Okay. Let's see here. So yesterday we were still talking about end behavior. This is the left side, as x approaches negative infinity. We're talking about the right side as x approaches positive infinity. Okay. All right. And what we're trying to do is determine the end behavior, but for rational functions. So we've been working with polynomials for a while, but now we're going to go ahead and focus on rational functions, actually for a good 2 or 3 weeks at least. Okay, so we're trying to determine, does a rational function have a horizontal asymptote, or does it have a slant asymptote? And the way we figure that out is going to be by comparing the degrees of the numerator and the denominator. Right, Reed? Right. So we have 3 cases here. If the numerator's degree and the denominator's degree are the same, we have a horizontal asymptote. We're going to divide the coefficients to find it. Okay. Case number 2, if the numerator's degree is less than the denominator's degree, we're still going to have a horizontal asymptote, but it's the x-axis, y equals 0. Now, the third case is the only one that we're going to have to eventually do some work, namely long division, but we're not there yet. If the numerator's degree is larger than the denominator's degree, then we have a slant asymptote, or what we say mathematically, that's a oblique asymptote. Okay, so it looks like we got through, I would say 2C. Is that what we got through? Yes. Okay. All right, so we're going to do D and E, and then we have 1 problem left. Okay, so we're only going to be on 1.7 for a few minutes. Okay, so for these last 2 here, we're still wanting to write a limit statement. So they don't give me the name of this function, so let's name it. Let's go ahead and say this is function f. Okay, so the left side, the limit as x approaches negative infinity of f of x, and the right side, the limit as x approaches positive infinity of f of x. Now, for this one, what kind of asymptote does this rational function have? Is it horizontal or is it slant? It's definitely what? It's horizontal, right? Remember, we're talking about what's going to happen as I push out in both directions on this graph. Well, this curve here, it's going to approach the horizontal asymptote from below, and this curve here, it's going to approach the horizontal asymptote from above. What is the horizontal asymptote? It's 2, y equals 2. So these limit statements here, the further out we go, the closer we're going to get to the asymptote. So that's the answer to my limit statements. Okay. We're going to get incredibly close to 2, but we're never actually going to be able to touch it. Okay. All right. So E is going to be really similar. Now this one, they don't give me a name either, so give me a letter. B? H? Okay. So let's say this is h of x. So I want to do the exact same thing. Let's write out my limit statements. So the limit as x approaches negative infinity of h of x, and the right side, the limit as x approaches infinity for h of x. Okay. Now, don't say it out loud. Think about what we discussed yesterday, what we just said a few moments ago. Okay, looking at our graph here. Write down what you believe each of these will equal. Okay. Okay. Audrey, what you got? -1. That's exactly right. Now, both of these are approaching -1 from above. That's the horizontal asymptote. So that's what my limit statements are going to equal. There we go. That's all there is to it. Okay. Questions? Easy, easy. Okay. Now, let's take a look at this box one more time. We used this for 2C yesterday, but it's going to help us with this last problem. If the degree of the numerator is exactly 1 greater, that's important for this problem, okay? Then the degree of the denominator, a rational function, will have a slant asymptote that's parallel to the ratio of leading terms. Okay, so with this in mind, let's come on down to our last example 3. It says, which of the following rational functions has a slant asymptote parallel to the line y equals 1/2 x? Well, if you just go ahead and look at your leading coefficients from f all the way down to k, 1/2, 1/2, 1/2, every single one of them has a ratio of 1/2. So what we're going to need to do is look at the degrees and figure out which one has a slant asymptote that's going to work. Okay. So take a few seconds, find me the answer. Is A, B, C, D, or E? And then we'll go ahead and talk about it. Remember, be careful on this one. Okay. You think we got an answer? Okay. Who wants to share it with me? Okay. Harrison, what'd you get? C is correct. Is C. All right. So let's go ahead and run through these real quick. All right. For F, the numerator's degree is 2. The denominator's degree is 2. So this is actually case number 1. This would have a horizontal asymptote, so y would equal 1/2, not 1/2 x. It's not a slant asymptote. So 1 is out. Okay. What's wrong with 2? Or function g? What case is this? There we go. So this is case 2. So the numerator's degree is 2. The denominator's is 3. Okay. The numerator's degree is smaller than the denominator's, so it is the x-axis. This one also has a horizontal asymptote, so 2 is out. Okay. Now 3, if I take a look, the numerator's degree is 2. The denominator's is 1. This is case number 3, where we're going to have a slant asymptote. Okay. Now, what's the problem with 4, though? There you go. Okay, here's the thing. The degree up top is 4. The degree down below is 2. So technically, this is still part of case number 3, where the numerator's degree is larger than the denominator's. But this is not going to be the type of slant asymptote that we're accustomed to. I would say in here, the vast majority of the time, if we have a slant asymptote, it's going to be linear. That's going to be because the numerator's degree is exactly 1 more than the denominator's degree. But Akil just said it. Okay. This numerator's degree is 2 more than the denominator's degree. What kind of asymptote do you think that's going to be? What kind of polynomial has a degree of 2? Quadratic. This right here will have a quadratic. Lord, this woman is loud. There we go. We have a quadratic asymptote. Okay, and that is very, very possible. So instead of a linear asymptote, okay, you're going to have a quadratic that the curves are going to go ahead and try to hug just like a linear. Okay. So that even though technically it's a slant, that's why 4 is out. Anybody happen to choose 4? That was, if anybody had gotten it wrong, typically that's what people chose today. All right. That's 1.7. How we doing? Okay. Now, you got 1.7 assignment right here. We're going to talk about this on Monday. Okay. Is this material on your exam? Yes. 1.4 to 1.7. Now, what we're about to start, 1.8, that is not on your exam. We'll have a quiz over that later. Okay, so let me go ahead and get set up for the next class. Okay. 1.8. All right, so this is to help out the folks who are going to be gone tomorrow. So the title is Rational Functions and Zeros. So the goal of this lesson is we need to be able to solve rational inequalities. So we're going to be bringing sign charts back. Okay, so it says recall a rational function is a function that's a ratio of two polynomial functions. Okay, we know that from the previous lesson. There's an example. Now, we explored polynomial inequalities in 1.5. In fact, you had one on your quiz yesterday. Now, we can utilize some of those concepts to help us understand more about rational functions. Okay, so let's see what we got here. Two important traits of a rational function. So if I have a rational function where g is divided by h, they're both polynomials, but they don't have any common factors, then we know two things. The function f has zeros when the numerator g equals 0. Okay? And two, the function f is undefined when the denominator h equals 0. Now, think back to 1.5 when we were working with a polynomial inequality. We factored the polynomial, we found its roots, we created the sign chart. We're doing the same thing here, but we have to look at the numerator and the denominator. Okay? Any value coming out of the numerator, we're going to call that a 0. And we're just going to define it with that 0. Anything coming out of the denominator, that's undefined. Okay? We're going to define it with the no solution symbol. Okay, so let me give you a quick overview of what we're going to be doing here. So number one, make sure the inequality has 0 on one side. You want it greater than or less than 0 so that you know what intervals to choose, positive or negative. Okay, number two, make sure that it's just one fraction, okay, one quotient. Number three, set both the numerator g and the denominator h equal to 0 and find the values that are going to go on your sign chart. Okay. Number 5 is super important, and this is what people tend to forget. Be careful to mark the values of h equals 0, your denominator, so that we never include those values in our solution. Okay. Look at each interval, decide if it's positive or negative, and then based on that, answer the question. Choose the positive or negative intervals. Remember, if it's a closed circle, we're going to have brackets. If it's open, we're going to have parentheses. Okay. So let's try an example. Now, this is the perfect type of example to start with because it's one fraction, it's compared to 0, and it's already been factored for you. Okay. All we have to do is dive right into the sign chart. Okay, we got x minus 2 over x plus 6 times x minus 3. Now, even though we've got a rational function, I'm going to take each part separately, the numerator and the denominator, and we're going to set them equal to 0. Okay, this is where I'm going to get my values from. So what if x minus 2 equals 0? What do I get? So we get a positive 2. And what are my other two values? Negative 6 and positive 3. So this one's only giving me 3 values for my sign chart. Okay, but just like before, I'm going to put them in order. So we're going to have negative 6, positive 2, and a positive 3. Now we have to decide open or closed. What do you think? Closed. We do have equality, right? This is what step number 5 was concerned about. I am going to go ahead and include 2, but I'm going to go ahead and put an open circle on -6 and 3. Why? It's undefined. What is the one thing you can never divide by? 0. So if I included those, what we're saying is it's okay to divide by 0. That's not going to happen. Okay. Now, up to this point, I mean, everything is still the same about the sign chart. Here's really the only big difference. Okay. When you go ahead and create your sign chart, you want to identify where they came from. Any value that comes out of the numerator, that's a 0. Because that's where 2 came from, I'm going to put a 0 atop of it. Okay. -6 and 3 came out of the denominator. Those are my undefined, so I'm going to label those with the no solution. The idea is that if somebody were to come along and look at your work, if they didn't see the problem, they would immediately be able to see your definitions and know where those values came from. Is everybody okay with that? Okay. All right. So let's go ahead and figure out where the pluses and the minuses are. How do I do that? What did we do for the previous sign chart? Okay, so Ayla, give me something between -6 and 2. -2, perfect. Okay, let me do this in a different color so it'll stand out. So let's say -2. Now, because I have a rational function, I'm going to represent each of these 3 groups, okay, with just a positive or a negative. So a -2 minus 2, that's a negative number. See, that's at the top of the fraction. So I'm not interested in the value. I only want to know, again, positive or negative. Okay. Now, a -2 plus 6, that's a positive number. And -2 minus 3, that's another negative number. So you see how I'm representing each group with just a symbol? Okay. So what's a negative over a negative? That's a positive. It's exactly what we were doing in 1.5. It's just that we've labeled what kind of values they are. Okay. Now, sometimes, like here, between 2 and 3, you won't have any choice but to go with a decimal. So I'll go ahead and choose 2.5. So I'll plug in again. 2.5 minus 2, that's a positive. 2.5 plus 6, that's a positive. 2.5 minus 3, that's a negative. So that's a negative interval. Okay. Everybody seeing what I'm doing? Is anybody having a hard time? Okay. Alexandra, give me something bigger than 3. 4. Okay, so I'm going to plug that in. 4 minus 2 is a positive. 4 plus 6 is another positive. 4 minus 3 is a positive. So that's a positive region. Okay. And William, finish it up. I need something smaller than -6. -10. Perfect. So let's see. -10 minus 2, that's a negative. -10 plus 6, that's a negative. -10 minus 3, that's another negative. So what would that give me? That would be a negative. Now remember, the sign chart is telling you what's happening graphically. What does it actually mean when I get a plus or a minus? What's that telling me about the graph? There you go. Like if whatever this looks like, if I were to graph it in my calculator, because I have a plus between -6 and 2, I know the graph would be above the x-axis there. So any interval where I get a negative, that's where it's going to be below the x-axis. Okay. Now I'm ready to get my final answer. Do I want the 2 minus or the 2 plus? How do we know? See, this is why we always compare it to 0. Because it's greater than 0, I want the positive intervals. Okay. Now remember, the sign chart, that's your work. Okay. The final answer is going to be to take your shading and write it as an interval notation. So for this one, I'm going to say parentheses -6 to 2 bracket union parentheses 3 to infinity. And there we go. Any value I take out of those intervals should make it a true statement. That's a solution. Okay, so now we're using a sign chart for a rational inequality. Okay. How are we doing? Okay. Any questions? Anything confusing anybody? Okay. All right, so we have just enough time to go ahead and do one more. What I want you to do, I'm going to give you 2 minutes. Try number 2. Okay, the only difference between what we just did and what we have to do now, they haven't factored that for us. Okay, so I'll at least go ahead and get that ball rolling. Difference of squares, what would that give me? X minus 2 and x plus 2. Okay. 2 numbers that I'll multiply to give me 25, but add to give me negative 10. There we go. Now, this is something I want to bring your attention to. Because both groups are the same, I'm going to go ahead and say x minus 5 squared. But even if you were to leave it as x minus 5 times x minus 5, that changes nothing. Okay? You'll still be able to get the answer you're looking for. Okay. All right. So let me give you a little bit of time. Try that out. Let's see what we got. What was y'all's bonus question yesterday? The snuggly duckling. Okay. So that would be. Okay. So I'm going to go ahead and keep that so I can get it in the grade book. Okay. That's what the bonus points. You want me to show you? Because the only thing I messed up on was that should have been minus 6 instead of minus 2. Yeah, but 3, 3, and then the work was 4. All right, so let me catch up to you real quick. What 3 values are going on my sign chart? Okay, negative 2, 2, and 5. Negative 2, 2, and 5. Okay, so I'm going to put those in order. Negative 2, 2, and 5. Okay. We don't have equality, so they're all open circles. Okay. What value or values are my zeros? What values came out of the numerator? Negative 2 and 2. So they're my zeros. 5 came out of the denominator, so that's my undefined. So now let's choose a number, something between negative 2 and 2. Okay, negative 1. Okay. So I'm going to plug it into these 3 groups that I have. So let's see. Negative 1 minus 2, that's a negative. Negative 1 plus 2, that's a positive. And now, negative 1 minus 5, that is a negative, but because I have it squared, that's going to end up being a positive. So this one right here, that's a negative region. Okay. Now, in fact, if you went ahead and did the same thing for the other intervals, you'll find that all 3 of the remaining intervals should be positive. Okay. Did anybody want me to choose another number and plug it in to show you? Okay. So what am I looking for here? The 3 pluses or the 1 minus? We're less than 0, so I want the 1 minus. Okay. So this one only has a 1 interval answer. It should be between negative 2 and 2. There we go. Questions? Okay, so for those folks who aren't going to be here tomorrow, we're just going to practice more of these. We're not moving on to a new lesson. Okay. So we'll continue the notes, but basically you see exactly what's going on here. And then on Friday, we got that activity with this material. Okay. let's go ahead and put all that up. If you want to get the calculators up here, you can go ahead and grab your cell phone. Okay, we're done.